So we got to take a look at outliers. Outliers are a consistent problem in a lot of data sets where you have cases that kind of don't fall in with the rest of them. And the question becomes, how do you, one, identify outliers, and then two, what do you do with them? In fact, a lot of the same issues arise in outlier detection and outlier management that arise in dealing with missing values. In fact, one strategy would be that you could simply deal with the outliers like a missing value. You either exclude them completely or you impute some values on those cases for the various variables that may be making that an outlier and then put it back in a data set. But the question, of course, boils down to how exactly do you figure out whether a particular data value is an outlier? The bottom line is that outliers or extreme values, they can really skew the analysis of the data. And it also means that if you include them in any type of a machine learning model, that they probably going to really impact the predictive power of that model. For example, let's say you've got sales prices for homes and you've got 1,000 records for sales prices, 1,000 cases, and then there's a few homes in there that sold in the millions of dollars, whereas everything else sold for $200,000 to $300,000. So clearly they're going to skew a whole bunch of things, and if you start building regression models or other types of statistically based models around that data set, you're going to end up having very skewed, very heavy bias in that, and it can really mess with your predictive power. You're probably going to overestimate a lot of the home prices because of those outliers. So you got to think about what you're going to do with that. And of course, before you can remove them or somehow maybe impute some values for them, you're going to have to detect them. So one strategy, particularly when it comes to a vector of values, is to simply look for those that are kind of on the extreme. Now, suppose you have a data set, and again, let's take a very simple one. You have home sale prices, and you have a whole bunch of sales prices. Let's say 1,000 of them, and you calculate the mean at somewhere around $350,000, and then you calculate the standard deviation, whatever it is. Let's say it's $25,000. Well, if you got a few extreme home sales, let's say you got a few of them that are sold for 3 or 4 million, maybe have a couple homes that are sold for like $1. Sometimes happens because there is a transaction within a family where someone wants to simply transfer the property to somebody else, but it still requires a sale price. So often $1 is used as a sale price. So clearly you want to exclude those from your analysis. So one strategy is to simply look for how far away the data value is from the mean. And the best way to do this is to use the standard deviation. So you calculate the standard deviation, and then you look for any value that's more than 3 standard deviations away from the mean. If it's greater than 3 standard deviations, you exclude it. If it's less than 3 standard deviations away from the mean, you exclude it. Now, this notion of using 3 standard deviations is fairly common, but it's not universal. For example, if you find you have a data set that is very centrally located, meaning most of the values are very close to the mean, and your standard deviation therefore is very small, then outliers might be data values that are 1 standard deviation, 1.5 standard deviations away from the mean. So don't look at that 3 standard deviations away from the mean as the cutoff point, as the clear cutoff point that you have to use. It really is up to you, and it's an interpretation that you bring to this, and you got to use your assessment, your opinion, your interpretation as a data scientist to determine whether you exclude that or not. Now, rather than determining whether you have data cases that are outliers computationally by looking at the standard deviations and how far away they are from the mean, you could also discover it through a plot. Build a scatter plot. Plot your data and see which ones are kind of far away. And then you can say, well, geez, anyone that's visually is that far away from the mean, that's the ones I'm going to exclude. So let's say you're plotting, let's say, the home prices on a line, and here's your 0 point, with a 0 point over here, and here are your prices. You have one house here, you have one house here, a lot of them are here, and they have one over here. Then you can visually kind of see that most of your houses are clustered around this point. So basically anything over here and anything greater than this would be outliers. That would be a visual detection of your outliers. So what you do with them really is up to you. Like I said, you have to think about how the outlier can influence or skew your analysis. So that's an important question you have to ask yourself. And then depending on how you view that impact potentially, you may choose to define outliers at a different level, or you might choose to exclude them. Now, particularly when you calculate means, you're going to have to think about how much that mean or that standard deviation could be affected by outliers. And you might decide that the effect is too stark, and you may want to go ahead and eliminate the outliers because your descriptive statistics are really affected by them. You also have to think about what it means to remove them. And you have to kind of decide whether you want to remove them or not, because remember, if you're removing outliers, you're essentially suppressing some of the data. And it could simply be that the data that you have and what you're dealing with simply has high variance, that extreme values are not unusual. That might skew everything, but they're not unusual. Which means if you exclude them, you're going to build a model that is biased towards the mean. And you're probably going to do predictions that occasionally may significantly underpredict. Now, of course, if you do exclude outliers from your analysis, you're going to have to report this. So you're going to have to make sure that as part of your analysis report, as part of your data report, as part of your report answering various questions or producing an algorithm, you have to state how you deal with outliers. And if you are removing them, you have to state so. It's one, an ethical requirement. Sometimes it might be a legal requirement. It's most clearly one that you have an ethical obligation for as a data scientist. You can't just simply suppress data and say, oh, I'm ignoring it because it's not right. Now, there is one case where ignoring them might be appropriate, and that is if it turns out to be measurement error, or if it turns out to be recording error. So let's say that you were asking somebody to type in home values from records they've obtained from some government office. There is no way to get the records electronically, so you have a whole bunch of paper that you print out, and then you have a data entry person type them in. Well, maybe instead of typing in $135,000, that typed in $1.35 million. Maybe they put an extra zero in. So in that case, that is not really a measurement error, but it's a data recording error. And it's not really part of the data, it's simply a mistake. So you got to think about what it means to have an outlier. It may just simply be that there was a recording error or that something was incorrectly measured, rather than being present in the data. Now, those clearly are cases you would want to exclude, or at the very least, you want to identify them and then hopefully be able to locate and repair the data, locate the data, the correct data, and then repair it. So basically update the record to reflect it's 135,000. So I've pointed out that an outlier is a value that is a certain distance from the mean. So how do you do that? One of the simplest things you can do is to calculate for every one of your data values the z-score. So the z-score is basically the distance that a particular data value is away from the mean. It's actually a ratio. It's how many standard deviations it is away from the mean. So if you have the mean for a data set, and you have some data value, so let's say your mean house price, sale price, 132,500, and you have a particular value, let's say 72,000, then what you do is you subtract that to get the delta, and you divide that by the standard deviation for the data set. That basically tells you how many standard deviations that particular property right here is away from the mean. If that number is greater than some threshold, let's say typically 3, then you want to exclude that value. You can do it either by saying that the absolute value is greater than 3, or you can say it's plus minus 3 standard deviations away, because clearly that could be a negative number. Because, for example, if 132,500 as the mean, and you have a value that is, let's say, 427,000 for home sale price, then that number clearly is negative. So then that case you're looking for less than -3. Or really what you're looking for is the absolute value of that is greater than 3. But again, it is subjective, and it is something that you need to do as a data scientist. You need to make that judgment call. So let's look at an example in R. Let's say for the sake of example that I have some data vector. All right, it could be a column in a data frame. Could be just a list of values. I made one up here. It just have a series of values: 4, 7, 12, 3, 43, 22, 18. So of course, to calculate the to do anything but outliers, you got to first calculate the z-score, which requires knowing the standard deviation. So let's calculate that first. So you get the standard deviation. It's SD of data set D. I assign it to a variable S, and it happens to be 14.0102. So now the next thing I have to do is I have to calculate the z-scores, which is the delta between each one of the values and the standard deviation. The distance between the mean and the standard deviation. So we got to calculate the mean first. Let's go do that. So we got the mean, calculate with the command mean. So to calculate the deltas, you simply use m minus d, but you really want to get the z-scores, so we're going to have to do a little bit of division. So here they are. Here's my z-scores. Could have done, of course, that as part one, simply as part of one operation. Could have simply said z is m minus d divided by the standard deviation s. It would have gotten the same vector. So now the question is, I got to figure out the ones that are more than 3 standard deviations away from the mean. By the way, you notice here there's none that are 3 standard deviations away. We do have a few that are a little bit smaller. In fact, one of the things you can do is you can collect the average z-score. You know what it is. Yeah, it is minus 3.17. But we should use the absolute value for this. Actually, let's do that. That makes life a little bit easier for us. Here you go. So that's the absolute value of z. So I don't worry about negative or positive anymore. And the average z-score is 0.73, which basically means that maybe using 3 standard deviations away from the mean is not really appropriate. Maybe really anything that's more than 1 standard deviation away from the mean would be considered an outlier. So let's go find those that are bigger than 1 standard deviation away from the mean. So one of the easiest way to do that is to use the which command. So which z-score has greater than 1 using the vector z. Assign it to O. That gives me my list of the indices into my data vector that has anything more than 1 standard deviation away from the mean. My data vector was D. So D sub my outliers would give me 43. Now, of course, what I can do is I can get a new data set. So data set with outliers removed. So it's called D dot no outliers is D sub minus O, meaning I'm getting everything but the outlier. So now I have my new data set with all the outliers removed. So that's one way you can deal with outliers. Now, what we have looked at so far is outliers in a vector, but what happens if you've got cases that involve more than one feature, more than one variable? So there's a built-in data set I'm going to use for this example. It's empty cars. So it's basically a list of cars that for each car collects miles per gallon, the number of cylinders, the engine displacement, the power of the engine, the horsepowers, and a few other sort of mechanisms. Also 1 and a 0 to see whether it's automatic or manual. And you get a whole bunch of them right here. So it's pretty straightforward. All right, number of carbs, number of gears, and so on. The question though is this that I have for you: is any one of these cars an outlier in this list? See, it's a lot easier to sort of say, oh well, I'm going to find the car that is an outlier in terms of miles per gallon. Or I'm going to find a car that's an outlier in terms of displacement. What we've done so far is we looked at a single column and said there is an outlier here because that particular column's value is more than a particular set of standard deviations away from the mean. But what if you want to look at all of them? Then it becomes a much more difficult problem. Because then basically what you're looking for is you're looking in some fashion to plot the cars along multiple dimensions. You're basically saying, well, there is a car and that's the horsepower, Maybe that's the miles per gallon. And maybe that over here is displacement. I'm going to look at outliers across three variables. And there's my various cars in this three-dimensional space. Maybe there's one over here. So now the question is, can you form a cluster around the normal cars, and then any one that kind of falls outside that cluster is an outlier? And how would you do that? Well, for that, you need a machine learning algorithm. You really can't do this easily. And the most common algorithm for that is K nearest neighbor, KNN. And you basically say, well, I'm going to find for each car the closest neighbors, and then if that distance between that and the closest neighbors is more than some predefined threshold distance, then I'm going to simply treat that as a particular outlier. So basically looking at clustering as a way of helping us do that. But that's something that involves a lot more than just simply looking at a statistic. This number involves a computer science algorithm to help us do this. This is no longer in the realm of statistics. So we're now going into that part where we talked about this before, where we are at the intersection between computer science and statistics. So we use statistical techniques up to this point. Now we're taking advantage of computer science algorithms to help us do certain work. And of course, if you have tens of thousands or millions or perhaps billions or trillions of cases, then finding the ones that are outliers becomes a computationally very, very difficult problem. And you have to use computers to do that. Now, there is an article that I put up for you that summarizes a number of different algorithms for doing outlier detection in R. And as you read through those articles, if you're interested, you will notice that there's a lot of different approaches that people have taken over the years to detect outliers. It's, again, an unresolved problem. There are differences in opinion as to what really constitutes an outlier, whether they should be removed, how you recognize them best. And of course, clearly for different data sets, different problems work better. So this is not one of those areas where you can simply say, oh, this is definitively the way you do this, but rather you have to put a little bit of interpretation into this. This is more of an art now rather than a science. In any case, at this point in time, you have a pretty good idea as to what an outlier is. At least you can detect them in terms of vectors. And you know that as you are scaling this into multidimensional data sets and multidimensional data points, that it becomes a machine learning algorithm. And we're going to address that soon.